All right, here we go. We'll zoom in a little bit. 13 questions on the test. So, Friday, those of you who take your time through each question might not get done with this during the class period. So, you might want to think about making sure you come in right after school to finish it or make other arrangements if you have after school stuff. Okay? So, because you only have so much time. All right. So if this is 26.3 right here, this is 106.9, and this is 63.8. How do we find?
Excuse the interruption, staff. I sent an email. I need you
to look at. I got it.
So please make sure you check into that. Thank you.
What's it about? The state fire marshal report about what we can have and what we can't have. We can't have anything hanging on the door because that's a fire hazard. So paper is a fire hazard? I guess so. So we can't hang tornado drill or fire exits on the door, the place where you would most likely put them, because they're a fire hazard. So.
No, but what about all the papers that are hanging right next to the door?
Well, that's fine because they're not a fire hazard, you know. I'm just saying, but whatever. Yes. Ganyo's gigantic power strip has to go bye-bye now. So they're ordering her a new one. A new modern power strip that is surge protected. That has a 25-foot cord on it. Okay, but hey, we're digressing. This is not Quartz's class. This is Mr. Bierschbach's class, so you have to stay on task. All right. So, how do we figure out angle beta? Yep. So we subtract.
It's 46.8.
And we get 46.8. That's good. We're reviewing then. Okay. So now that I have angle beta, if I want to find side A, I do the law of what? Sines, because I have opposites. If you have opposites, you do law of sines. If you don't have opposites, it's law of cosines. That was a quiz. Now we're taking the chapter test. So the first 7 questions on this are basically like the last one with a few minor other ones. So sine of 109 over 63.8 equals the sine of 26.3 over A. So if you take 63.8 times the sine of 26.3 press equals, divided by the sine of 106.9, A winds up to B.
I said 29.5. Am I Dylan?
Well, that was not pick on Dylan Day. All right. So, if we know that, can we try the Pythagorean theorem to find B? What? Pythagorean theorem only works on right triangles. Come on, people.
I told you that. That's what I said. I said let's not.
Let's not do that. So then how would we figure out side B?
You would do the same exact thing.
Same thing. Law of sines. The sine of 46.8 over B and the sine of 106.9 over 63.8. So 63.8 times the sine of 46.8 divided by the sine of 1. What? What do we get?
I got 48.6.
No.
What?
Yes. 48.6 would make sense. Well, I have a beef against her, so, you know.
Why?
I've only reminded her. All right. When you have a problem with side-side angle, okay, and there's multiple, and you see this when it comes up. Just draw your two triangles right away. All right. Beta, whatever the angle they give you, put down the lower left-hand corner, make it 30.4. Alpha must be here because we're going to put A opposite of that. Okay, because that's the first angle you're going to be finding. And B is 29.5. So you got 30.4, its opposite side, and then the other side that you don't know, put up here, not on the bottom. So alpha goes here, gamma goes here. Okay? Then you can draw your second triangle right away, which, again, put them in the same spots. 30.4, 29.5, 37.4, alpha, beta, gamma. All right. So how do I find alpha in the first one? Law of sines, because we have opposites. Sine of 30.4 over 29.5 equals the sine of alpha over 37.4. So take 37.4 times the sine of 30.4, press equals, divided by the sine of, divided by 29.5, press equals, and then do inverse sine of the answer. What does alpha wind up to be? 39.9. Okay? So that's what alpha is in the first triangle. Then what I usually do is immediately go to the second triangle and figure out what alpha is over here. I don't do law of sines or anything. I just subtract. Subtract what from what? 180 minus 39.9 is 140.1. Now that I have two angles, I can find my third angle of each. So 39.9 plus 30.4 is 70.3. If that's 70.3, this is 109.7. 30.4 plus 140.1 is 170.5. So this is 9.5. So now we have all the angles of each. Now I just have to find C of each. See, in the first one, we take what we were given at the start, the sine of 30.4 over 29.5 equals the sine of 109.7 over C. Cross multiply and solve. So take 29.5 times the sine of 109.7, press equals, divided by the sine of 30.4, press equals, and what do we get? Okay. And then in the second one, we take the sine of 30.4 over its opposite, 30.4, Mr. Bishbach, over its opposite side, 29.5, equals the sine of 9.5 over its opposite side, C, which is 9.6. So you got to know where to put the answers, okay? The top line is the acute triangle. The bottom line is the obtuse triangle. So alpha is 39.9, 109.7, and 54.9. The bottom triangle is the obtuse, 140.1, 9.5, and then 9.6. Okay. On the next one, looks like we have two triangles again. But before I draw them, I all of a sudden notice what about this, Maggie?
I don't know, actually.
Why did I underline this so heavily?
Because that has to be the one that lines up with the smallest one. That's the obtuse one.
That's the obtuse angle. How many obtuse angles can you have in a triangle?
Only one.
Only one. So instead of drawing a acute triangle, is there any reason to draw an acute triangle? No. So let's just draw an obtuse triangle. So this is 130.4. Its opposite side is 6.6. Let's make alpha here, so its opposite side is 9.8. Okay? So, now what should I do? Well, sine of 130.4 over 6.6 equals the sine of alpha over 9.8. Don't shout out the answer. Let everybody do this first. So 9.8 times the sine of 130.4 divided by 6.6 equals what? Okay, now you can shout out the answer. 1.1? So you do the inverse sine of the answer.
So it's no solutions.
You can tell it already.
Yeah, for all those who punched it in
I
there.
said that too, and you didn't even let me finish my answer.
Whatever. For all of you who were punching in the calculator, you could have looked at this and said, the biggest side. You didn't say that, Maggie.
That's what I was trying to say at the beginning. Yes, I did. I said it lines up with the smallest side.
Yeah.
You can't have an angle bigger than that in a triangle.
Yeah.
That has to go with the biggest side.
Yeah.
I was right and you didn't let me finish.
Yep, I didn't. I'm such a meanie.
Yeah, you are.
So the biggest side is not opposite the biggest angle. So no, that doesn't work because the biggest side has to be opposite the biggest angle. That doesn't work. There is no solution. Now, will Mr. Bierschbach automatically have number 3 as a no solution problem?
Yes.
Maybe not.
Yes, he will.
Okay.
You're such a liar.
I might change the test.
Oh, really? Don't do it. That's not fair.
I can't.
Well, you can.
I can,
You shouldn't.
but I don't know if I will.
I'll bring it back. Chloe brings back the journal. I have it back by tomorrow morning. You can't change the text.
Yeah, let's do that.
That one's fine.
No, I won't forget. I promise.
You know how
Well,
people.
you've been saying you won't forget since homecoming, which was 6 weeks ago.
I'm a little forgetful.
Okay. Lunar crater problem. I told everybody this is on the test.
That's
You guys should know exactly how to do this. Okay. Lunar crater. Side C. I'm sorry. Just a little ugly. Is that better, Maggie?
Yeah.
Okay, there's C. Now we know C is 44 from B, from A. A is up there.
That's what I meant.
A, B. There we go. 44 from A. BAC is 110, so this one right here is 110. ACB is 40, so that was 40. So I have my opposite of C, so it's, well, I know the sine of 40 over C. We got that. 110 is opposite of nothing that we know, so 44 is opposite of this angle. So if we knew this angle, then we would be in business. How big is angle B? 30. We know it's 30 because 110 plus 40 is 150, so there's 30 left out of the 180 degrees in a triangle. So if you go 44 times the sine of 30 divided by the 44 times the sine of 40 divided by sine of 30. There we go. And the lunar crater must be something bigger than 44. Because it says round to the nearest hundredth, so we need 2 decimal places. Try to remember that for tomorrow. Look, we have this side, which is 22.6, this side, which is 15.7, this side, which is 12.3. Side, side, side is law of cosines. I like to find my biggest angle first, especially if it's obtuse. Okay, but find the biggest angle first when you have side, side, side. So if I want to find alpha, I go a squared plus equals b squared plus c squared minus 2bc cosine of alpha. So on my calculator, I'll take this minus this first. So 22.6 minus 22.6 squared minus 15.7 squared minus 12.3 squared equals 112.98 equals, and then multiply these together. Negative 2 times 15.7 times 12.3 is negative 386.22. Divide by negative 386.22. Cosine of alpha equals whatever that decimal is, and then do the inverse cosine of the answer. So you take this divided by this and do inverse cosine of the answer. So it's 107 point whatever. So 107. Okay. So once we know that, then I know I have an obtuse angle. So the other angles can't be obtuse. They have to be acute. I use the biggest one first. So we can find beta next if we want. Now we use law of sines because it's faster. The sine of beta over its opposite side, 15.7, equals the sine of my angle 107.0 over its opposite side, 22.6. So if we cross multiply, oops, didn't mean to do that. Cross multiply. 15.7 times the sine of 107, press equals, divided by 22.6, press equals. Take the inverse sine of the answer. What is our answer? 41.6. If we add these together, that's 148.6, which gives me 31.4 left for this one, correct? Okay, we found our three angles. Just slightly easier is side angle side. So, how do we find side B? Law of cosines, because we don't have opposites, so we can't use law of sines, so it's law of cosines. So B squared equals A squared plus C squared minus 2AC cosine of 98.5. If we do the math, we get some hideously big number, and then we take the square root of that, and we get what for B? Round to 4 decimal places. 12.3991. So then, I already have an obtuse angle. I know I can use law of sines and it'll work out just fine. So I go the sine of 98.5 over its opposite side, 12.3991 equals the sine of alpha over 10. Take 10 times the sine of 98.5 equals, divided by 12.3991. Press equals, inverse sine of the answer, and we get 28.6. And then 28.6 and 98.5 is 127.1. So to take 180 minus 127.1 is 52.9. All right. Heron's formula. How do we start out Heron's formula? S equals A plus B plus C divided by 2. Okay? 4.4 plus 8.9 is 13.3 plus 10.6 is 23.9 divided by 2 is, I don't know, 11.95. I've taught math for a long time. I play with numbers every day. You play with enough numbers, you get good at it. So area equals S, 11.95, times S minus A. S minus A would be 7.55. S minus B would be 3.05. S minus C would be 1.35. And you do the math, and what is the area? Not super big. 19.3. The next one. When you're given angles instead of all sides, you try to do the side angle side formula. Alpha, beta, gamma. Doesn't really matter where they're at. 46.7, 60.6, and C is 15.4. So I'm at angle, side, angle. I want side, angle, side. So if I'm angle, side, angle, how can I find another side easily? Use the law of sines or law of cosines? Law of sines. So I have to figure out this angle gamma down here. Now if we add these two, 46.7 plus 60.6 is 107.3. So 180 minus 107.3 is 72.7, correct? So, which side do you want to figure out? A or B? Doesn't matter. We'll go with Dylan. The sine of 46.7 over A equals the sine 72.7 over B, or over C, 15.4. So 15.4 times the sine of 46.7 times the sine divided by the sine of 72.7 equals what? 11.7. So to find the area equals 1/2 side angle side. So 15.4 times 11.7 times the sine of the angle in between them, which is 60.6. If you do the math, that's over 100, so half of that is 50 something times the sine of 60 is probably 30 something, 40 something, somewhere in there. What do we get? 78.7. I was off. 78.7.
Wait, no, 78.5.
What about the entire?
Okay.
The entire answer.
The entire answer, yeah. So, probably should do that. So instead of rounding this to 11.7, we should leave this out to about 4 decimal places at least, or else put the whole answer in, because that might throw us off a little bit. Okay, are we good? All right, and then to vectors. Yes, I totally got that right when he said that. A is 0, 4. B is 5, 0. What's A plus B? What's A minus B? Negative 5, 4. Because you take 0 minus 5 is negative 5. 4 minus 0 is 4. So A plus B is at 5, 4, which is this one. A minus B is negative 5, 4, which is this one. A for this problem is 3, 4. B for this problem is 5, 2. What's A plus B? 8, 6. What's A minus B? Negative 2, 2. So A plus B is 8, 6. That's the furthest one going out this way. Negative 2, 2 would be just a short little arrow, which would be that one. Which arrow is at 135 degrees? C is. Magnitude and direction of a vector. Okay. What quadrant are we in at 3, negative 1? Quadrant 4. We're somewhere over here. Okay. All right. For the magnitude equals the square root of 3 squared plus negative 1 squared. Which is 9 plus 1, which is the square root of 10. It says type it in a radical form. We leave it as the square root of 10. Okay? Direction. What trig function do we use to find direction? The inverse of tangent. And we put y over x and leave them positive. Okay? And we get, I don't know what we get. How many degrees? 18.4. Now it's 18.4 degrees down from here. What we want is this vector or angle. So we take 360 minus 18.4. $41.6. 341.6. Yep. And last but not least, the donkey problem.
Your favorite one.
Of all time. All right. So if this is a 20-degree angle, the prospector in the blue shirt, the angle up by him would be what? How many degrees is that angle up there at top? 160, because these are supplementary. Okay? So 50 is here, 80 is up here, 50 is over here. We draw the line of the force. There's a force going this way from them pulling, and then the donkey is pulling back at the same force. Okay? So, to do this, if this is x, we say that x squared equals, law of sines or law of cosines? Cosines, 50 squared plus 80 squared minus 2 times 50 times 80 cosine of 160. Now, if they were in a straight line, they'd be pulling at 130 pounds of force. 20 degrees is not very far away from pulling in a straight line, so it's got to be really close to 130. So if you do the math, what do we get?